Okay. So for today's lecture, we'll go for the chapter number 6. About the induction motors or induction machines. At the first, we So as you know before that the induction motor is part of the AC machine. So basically you have two types of um, AC machine. The first one is synchronous machine and the second one will be asynchronous machine. So the induction machine is part of the asynchronous machine. So for the chapter 6 here, it explains on the three-phase induction machine. So as previously explained in the slides, so today I'll go for the we will do number of examples as in the textbook. In textbook you can refer to your textbooks. So this concept was explained before. Okay, and this is the air gap flow, the power flow. For the motors, you start with the input power, which is from the terminal voltage and also line, and then you'll have your stator and copper losses. Then go to the core losses. Then in between the stator and the rotor, there is an air gap. So here in this figure, it shows the transition of the power from the stator to the rotor. So that's called as the air gap power. So once the air gap power is transferred to the rotor, so it has to experience the rotor copper losses. Then after the rotor copper losses, you have your power converted. The power converted means from your electrical power is converted into the mechanical power, and then you'll have your and this the converted power is equals to the induced torque times the mechanical speed. So before the power can be used, so it has to minus the additional stray losses and also the friction and windage losses. So this friction and windage is due to the friction mainly on the bearings, and the windage is the losses of the rotor when it moves. So it's against the air, so more like you have the friction when you move something, so you have the how to the air. It's like the air friction, okay, so that's for the power flow. Then this is the example number 462. So I'll go for example 6.1. Where is it? 6.1. Okay, here. All right. So the example 6.1, it says a 208. Lambat ni. Hang ah. Okay. A 208 volt 10 HP 4-pole 6 Hz Y-connected induction motor has a full load slip of 5%. So what is the synchronous speed of this motor? So the synchronous motor, so this is quite straightforward. Mana conting? Tak boleh conting. I'll go to the whiteboard. Alright. So to find the synchronous speed, your equation is F equals to NP. So your N here is equals to F divided by P. So your machine is 60 Hz and has a 4 poles, means that the 4 pole is the number of poles. Your 2P is equals to 4. Okay, so your 2P is equals to 4 and your P is equal to the pole pair. So this is pole pair. So your pole pair is equals to 2. Then your velocity, the synchronous speed will be 30 revolution per second. So this is the 60 Hz is from source, from the fundamental source. Okay, so that's why. So this 60 Hz was supplied into your stator. Then that will be your reference for the synchronous speed. Okay, so that's for the number 1. Okay, so we change to the RPS, and then into RPM will be 30 by this 1 per second kan. And then you have your 60 second is equivalent to 1 minute. So your seconds cancel out and then become 1800 per minute RPM. So this is the answer for this one. And then what is the rotor speed? Now they ask you what is the rotor speed of this motor at the rated load. So your rated load is 10 HP. So it is given that for B, your machine has the synchronous the sleep of 5%. So your sleep is 5%. And then so now you need to find the rotor speed. So from the equation, the rotor speed is equals to 1 minus sleep and sync. So this is your mechanical rotation. So 1 minus 0.05 is your sleep by 8000 RPM. So you'll get your answer will be Sekejap saya kira dekat sini. You have 1 minus 0.05 by 1800. So 1710 RPM. So now you see there is a lag in speed between the synchronous speed of the in the stator as compared to the rotor speed. So this is because of the slip. Right. So now this means that your rotor is rotates at the different frequency from the stator. So if you want to find the frequency of your rotor, ada tak soalan kat sini asking for the frequency of the rotor? Alright, so what is the rotor frequency of this motor at the rated load? So you still use the same equation, F equals to NP. So here now your N is now refers to the rotor speed, and then now this one you need to convert first into per second divided by 60, and your pole pair is still 2. So when you this one divided by 60 times 2. So now your rotor speed, your rotor frequency is now rotates at 57 Hz. So itu ada perbezaan dia. Okay. So now we go for what is the shaft torque of this motor at the rated load. So kalau awak tahu the shaft torque adalah developed from the power output. So your power output will be power output equals to your torque dan juga your omega m kan. So what is your torque? So the torque of the load is equals to your P output adalah 10 HP, the rated frequency. So 10 HP times 1 HP is equals to 746 watt. Right, so 774 watt for 1 HP. And divided by the omega m. So omega m is your rotor velocity. So which is equals to this one, you have your omega equals to 2 pi n. So now it's 2 times pi n has to be per second. So 1710 divided by 60. So this is your torque. 1 HP cancel out. So you have your final value 7460 watt divided by this one, cancel out 30. So you get the kat bawah will be 171 divided by 3 times 3.142. So 179.09 like that. Okay, so 7460 divided by 179.09, you'll get your output torque will be 41.65 Newton meter. So unit mesti betul. Okay, so that's the answer for the shaft top, where the motor running at rated load. So ini ada solution dia. Cuma solution dia menggunakan the formula N synchronous equals to 120 F stator divided by P. So ini the equation yang dia menggunakan adalah when you use this equation, so your result will be already in revolution per minute. Tapi yang saya FNP, kita lagi it is better to use the base unit, the SI unit. So it's up to you if you want to use this one or to use F equals to NP. Okay. Alright, so this is the equivalent circuit of an induction motor whereby you have two separate equivalent circuit. The first one, this part is to represent the rotor, and the stator part, and the second part will be a rotor. So the principle of this induction machine is the same as the transformer operation. No, this one you can read through if you want to know detail about this induction curve. So now we go to this. All right. So this is the rotor model. Okay. So the rotor circuit model of induction motor. So when the machine is running, so now you have your equivalent circuit of the rotor. Yeah. So which consists of the represented as the induced source, the induced voltage, or the induced back EMF. So ER stand for the rotor equals to S E R naught. So R naught is from the when the machine is stationary. So if you refer here, all right, when your machine is stationary, any stationary, so you get your you can measure the voltage at the rotor. So the value will be it's like a transformation of the from the primary to the secondary windings, just like the transformer. So that's at the stationary. At the stationary, you measure the voltage at the rotor will be equals to no, the value will be similar to the one that you measure the secondary winding of the transformer. So that's in this context, they call it as a ER0. And then when the machine is running, so because of this asynchronous machine, so you will have sleep, right? So you will have sleep. Now we can simplify that the circuit by replacing the JXR, which is equals to SR SXR naught. So this one is equals to SER naught, and also R. This one is just rotor resistant windings. So the inclusion of S here represent sleep, and this shows when the machine is running, you can simplify the rotor circuit, something like this. Okay. So go to the example number 2, as you can see here. You have number 2. Hilang number 2. Okay, for example, number 2, 662, you have a 480 V, 60 Hz, 50 HP, the 3-phase induction motor, drawing a current of 60 ampere at 0.85 power factor lagging. The stator copper losses are 2 kilowatt and the rotor copper losses are 700 watt. The friction and the windage losses are 600 watt. The core losses are 1800 watt. And the stray losses are negligible. Find the following quantities. The air gap power. So kalau kita tengok balik, your air gap power is equals to your PAG is equals to the induced torque by mechanical velocity, angular velocity. So the information given here, to obtain the PA gap, if you look into the power flow figures here, okay, in order to have the air gap power, so the input power, you need to minus the static copper losses and also the core losses. And in order to get the converted power, the power air gap, you have to minus the rotor copper losses. And in order to obtain the output power, the converted power, you need to remove the friction losses and also the stray losses in the converted power. So if you look into these examples, now we are looking for the air gap power. So means that the air gap power, the power air gap equals to the power minus the static core losses minus the core losses, the static core. So your input power here will be, you see the 480. So in a 3-phase system, your power equals to set 3 V line, this one your I line, and cos theta, right? So everything you can refer here. So this gives you by 480 by 60 ampere by the power factor is in lag 0.85. So this gives you set 3 is equivalent to 1.732 by 480 by 60 and by 0.85. So which is about 42,399.36 watt. Okay, so this is your input power. So your input power minus 42,399.36. Okay, so it's this given your stator copper losses is 2 kilowatt, will be 2000 watt, and the core losses, where's the core losses? The core losses is 1800. So it's quite straightforward if you understand the power flow. Then minus 2000 minus 1800, so you get your air gap power is 38,599.36 watt. Okay. So number two, the converted power. So for converted power, so cakap tadi the converted power is P converted equals to power of air gap minus P copper losses of rotor. Right? So the copper loss of the rotor is given by 700 watts. So your 38599.36 minus how many? 700 watt. 700 watt, you will get 37.9 kilowatt. And C, looking for your P out. So this one you have your P in minus PAG minus P converted. Okay. Partners a lot to friction H minus dengan the miscellaneous or the stray loss pula. Answer dekat sini bagi tahu you'll get about 37.3 kilowatt. So into HP horsepower punya unit. So your 37300 divided by 746. So you'll get about 50 HP. So maksudnya apa yang ditulis dekat the information written in this equation that at this condition, this is the rated condition. So when your machine is supplied by 480 at 60 hertz, drawing current of this much and with this power factor, so your output shall be equals to 50 HP. So this shows you the amount the transformer operates at the rated condition. So when we calculate here, we get 50 HP. It's the same. So therefore, the induction motor efficiency straightforward. Also, power out divided by power in, and by 100. Okay, this is the formula for how can we calculate the stator copper losses when we have the current just like now we have 60 ampere, so we can use this calculate. And the core losses is given by the induced voltage and by the G is the core constant of losses, and then the aggregate power just a minus of this induced input copper losses of the stator and also the core losses. And you can relate the aggregate power when you have two is current. So it's since it's three phase, so the 3 by I square 2 R2 divided by S, also to include the slip. So this one you can refer to this up here from this lambat sikit bergerak. Okay, so it's from this figure 612. So this you can use this parameters to find the aggregate power, just like that. So from that equivalent circuit, they derive the equation of the power and torque in the induction motor. So finally, the converted power, you say the converted power can become like this to include the stator, the slip, and also the information in the R2 in the rotor part. And also you can simplify the losses of the rotor copper loss equals to as the slip times the air gap power. Okay. So for the top. All right. So the final torque will be this one. The T induced equals to air gap power divided by omega synchronous. The angular velocity, the synchronous angular velocity. All right, to be more clear on this explanation, so we shall go to the example 6.3. So when you have 460 V, 25 HP, 60 60 Hertz, 4 pole, Y connected induction motor has the following impedance. Right, so the total rotational loss now at first, when you have these figures, so you should visualize by your own figures. So basically you have this is your distance, and you have your organ. Okay, so now you, all right, so this is your input voltage. Okay, and here you have your load untuk rotor lah, motor. So now you need to include these figures, your R1, X1, R2, X2, and XM. So this is your JXM magnetizing under XM. So here is your JX2, this is your R2, this is your R1, and here is your JX1. Of course, here will be RC, which is equal to 0 lah, sebab dia tak bagi kan. Alright, so here will be your I2, and here will be your I1. Tulis yang tu dulu. And then the total rotational losses are 1100. I assume to be constant. So at any speed, the rotational losses sama saja. The core losses is lumped in with the rotational losses. Okay, so the rotational losses includes the core losses. For a rotor slip 2.2% at the rated voltage and the rated frequency, find the motor speed. So Now dia tak tanya for you to find the synchronous speed. They ask you at this 2.2% at the rate of voltage, find the motor speed. Maksudnya the rotor speed lah. So this is the equivalent circuit. So awak tahu the relation between the rotor speed and also the synchronous speed is, this is the mechanical rotation equals to 1 minus S. Jadi kan N sync. So your N sync is equals to F bahagi dengan P. Your machine's now at 60 Hz and pole pair is equals to 2 kan? Awak ada 4 pole machine. So your pole number is equals to 4 and your pole pair is 2. So divided by 2, you will get a 3 radian per second. Okay. So now your Nm is at sleep 2.2%. Okay, so 1 minus 0.022 times 30. So your speed's about 2934 RPS. Bila awak convert into 2934, you times by 60, so you will get the RPM figure 1760 RPM. Okay, so this is your rotor speed at sleep of 2.2. So you need to find the stator current. So the stator current was from where? The stator current mana tadi gambar? This one. Right. So this is equivalent of the induction motor. So when the motor runs at certain speed, so you need to include the sleep in the equation. And so this is, you have your copper losses kat sini. This is your copper losses. Sorry, this is your copper due to the copper resistance. Okay. So this is your I1. I1 is your stator current. So you need to find first. You need to find the equivalent resistance of this. So bila you dapat this equivalent, then you can use the basic equation of IS equals to V phase divided by Z equivalent. So now your challenge is to find the Z equivalent. To cut it short, you can refer to this. Alright, these figures represent this equation lah. Tapi ni nilai dia tak ada lah. So this shows you how to include all these parameters in a transformer like equivalent circuit, and then at the secondary you need to put the rotor resistance, and when you times with the sleep configuration, then it will become like this, and this is also equals to the converted power from here. You see, this is converted power. Saya cakap apa tadi ya? Alright, this is converted power. When you have I2 square, so by you can get the converted power lah. Apa saya cakap tadi? Nak cari dekat stator. So dekat sini dia tunjuk the equation. Okay, so the Z equivalent is R1 plus J X1 plus, so J6J, the parallel reactance tadi. So 1 over GC adalah 1 over this conductance, 1 over R, and BM adalah inductance, reactance punya inverse, and then 1 divided by this is the this is the resistance of the here resistance of the rotor bar or rotor conductor. So this one, when you simplify this, you will get like that. Then, so straightforward, you can find the stator current. Jawapan kat sini. Alright, so for the power factor, of course, when you so for the power factor, D power factor bila awak dapat when you find your I stator phase divided by Z equivalent, so you will get certain amount of the angle, the I would say Y degree angle. So your power factor is equals to cos this Y degree. So this you have to find by yourself. What is the stator current? Then now you are looking for the converted power and also the output power. The converted power, the P converted is equals to apa tadi? Yeah, for the 3 phase, awak ada I square 2, so by the I square R2, and then S1 minus S. Satu balik. One minus S bahagi dengan S. Kan? So if you look into the power flow diagrams, untuk converted power, your equation will be, we start from the P output. Your P converted minus P copper losses or rotor minus the P windage friction. Okay. Slide. Sebab P converted sama dengan apa? P out minus your P P copper kan, P copper, ni P, apa dah. First of course your windage and friction, and then the other one is P strain. P strain. So your power converted sama juga dengan the power of air gap minus P copper losses of the rotor. And your P air gap is equals to your input power minus P copper losses of the stator and minus P core. So the power input in three-phase cos theta. So here you will get, if you look into the solution, you will get about 12,530 watt. Okay. And then the stator copper losses equals, since it is three-phase, I1 square, so R1. So here we get the current 18.88 square times, so you get 685 watt. The copper losses dia dah lump into this is the core kat mana? The core, what it? Yes, the core losses dia dah lump together into the okay, copper losses, what is I get? Stator and also core losses. So kalau tengok dekat sini dia kata the rotation losses are assumed to be constant. The core losses is lumped into the rotation losses. So here they tak represent the core losses. The core losses already be part of the rotational dengan windage losses kat sini. Okay, dekat situ. So now your power air gap is equals to, so this one here dia tak mention dekat sini, just can remove this one. So the air gap power will be equals to 685. From calculator you will get about 11,045 watt. So that's the air gap power. Soalan dia sudah kita dapatkan P converted. So the converted power P, kita boleh menggunakan the equation which includes the slip, so which is equals to 1 minus S of the PAG. So 1 minus tadi apa? 2.2 kan? 2.2, so 0.02 by 11845 watt. So become eleven thousand five 11,584.41. So this is your converted power. Then your output power will be this P converted minus minus the P apa tadi? Kalau tengok power flow, PP friction and strain. So P windage and friction dan juga P strain. So basically this value is already in the power rotational process. Includes everything. Kalau baca dekat soalan dia kata everything is includes in the rotational losses are assumed to be constant. The core losses is dalam rotational losses. So which include the rotational losses lah. So this is part of rotational losses. So your 154.1 minus dengan 100. So your answer will be 10485 watts. Yes. So the induced torque tu dekat air gap. The induced torque in the induced torque is due to the air gap power. So the P air gap equals to torque omega, So here is torque induced divided by omega. Of the omega of the synchronous speed of the source. So your induced torque equals to P again, what is P again? 11.5 divided by omega the induced from the source. So the synchronous velocity tadi berapa kita dapat? About 30 kan? So 30 darab dengan 2 pi n. So 2 pi n kita adalah 3. So n synchronous. So 2 by 1 point 2 by 2 darab 3.142 by 30. So here you'll get your nilai will be 188.52. So 11845 divided by 188.42. So it's about 62.86 Newton meter. So this is your induced torque. Belum your output torque lagi. So the output torque is equals to the power output equals to output omega m, and then your T equals to power output berapa? 1085 by omega tadi kita dapat berapa ya? 1710 something kan. Okay, this one. Okay, 29.34 revolution per second. So It's 104. Kita calculator je. 104.85 divided by 29.4. So dapat dalam 3. Macam tak betul je. Dia dapat 39 ke 185 right. Situ the power output 10 and the T betul. Radian per second. Saya. So this one we need to times the 2 and 5. So it will be divided by 2 divided by 2. Dapat 56.75. 56.75 meter. So this is the output torque. Nampak tak dia punya kehilangan torque agak tinggi juga, about 6 Newton meter. And the motor efficiency, the efficiency is your P out bagi dengan P by 1000. Okay, the rest example you can try 6.5, 6.4. So when you do this example, you will be you'll be able to understand how to relate when we have the machine in motion, to relate the slip into the equation, to relate the slip into the power calculation of the machine. So I think for the asynchronous part, for the induction machine, the most important part is you should understand the equivalent circuit. So where are the parameters? For example, especially on the rotor side, when the machine is moving, so the final equivalent circuit will be like what? You have your GX2, you have your R2, and the important part is on the rotor copper losses. So your R2 to include the slip. So the R2 by 1 minus S divided by S. That's the part you need to know how to write where is the machine, where is the parameter will be. And so I think that's all. Ada soalan? So next week kita akan buat lagi sedikit lagi induction machine, iaitu untuk macam mana nak tentukan the maximum torque of the machine. So how we have the rated torque, dan juga the maximum torque. So bila the machine operates beyond its maximum torque, so of course the machine collapse kan. So how do we determine the maximum torque of the machine? Apa lagi? Alright, itu je kot. Anything? Other question? So next week kita akan buat, I think, so next week kita akan buat on the, sedikit lagi pasal, saya akan buat on the synchronous machine, sedikit lagi. This one is synchronous, so next week I will touch on the maximum torque and also some portion of the synchronous machine that have not yet been covered. So hopefully by next week kita boleh habis our syllabus. And also dalam ULearn, please check your assignment. Ada saya rasa ada assignment, so boleh buat. Dan also dalam ULearn tu ada macam-macam information pasal video, about the star delta punya start connection, how the machines work, semua ada dalam tu YouTube punya reference lah. So boleh lah tengok video tu dekat ULearn. Okay, tak ada soalan, kita boleh.
So lab 5 bila duduk je?
Lab apa? Lab 4?
Lab 4 lah tu.
Okay, lab 4 will be, bila saya bagi ya? So next week ya? Okay, untuk lab, this group, hantar dekat email saya saja. Hantar dekat email yang saya bagi. Apa nama? Lupa dah. Email mana ya? So jangan masuk ke dalam ULearn. Saya takut tercampur dengan dia ada section termix up. Sebab dekat situ dia set tarikh, so nanti tutup. Yes, Gmail. Yeah. That Gmail, everything on the labs dan juga assignment, awak hantar dekat Gmail tu dan pastikan you stated your names clearly and which labs. So that email tu memang saya buat untuk khas untuk this lah. Saya tak nak campur dengan lain. Sebab the issue is bila ada dua pengajar, so dalam ULearn tu akan ada, ni saya tak nak ganggu lah kalau boleh, saya tak nak ganggu. Saya cuma discuss on the material insight saja. So Encik Hatta yang uruskan on the material insight dan juga the lab sheet semua dalam tu, boleh ambil dalam tu. Tapi submission tu you don't have to put in your ULearn. You just send email to me. Betul? Email Google.
Email Google. Chapter 3 nanti masuk dalam ULearn boleh tu?
Chapter 3? E-books?
Chapter 6. Ni. Chapter 6 ada pun dalam ULearn.
Ada kan? Dalam e-book ada dua. Chapter 3 ya? Dalam e-book tu? Oh ya. Yang cek. Ya, e-books. Mana e-book Lecture notes, sini dah cantik. Okay, lecture note on AC machinery fundamental. Kita tengok jap. Ini si lecture notes. Oh, chapter 3 sahaja. Because of the fundamental, sorry. This one saya akan masukkan lah. Chapter 6. Saya akan masuk I'll do it. Okay. Alright, saya akan bagi sekejap lagi.
Okay.
Chapter 6 and chapter 5 lah kot. Chapter 5 on the... Chapter 5 saya bagi tahu last week kan. Chapter 5 ada tapi saya tak. Chapter 5 kita dah represent dalam slide. Chapter 5 adalah synchronous motor and chapter 6 the induction ataupun asynchronous motor and chapter 7 dia lebih kepada connection everything. Okay, saya tengok chapter 7. No, chapter 7 kita on the DC fundamental. Okay, so saya akan buat lecture note chapter 5 and 6. Saya akan bagi e-books ni lah. So you can do. Okay, betul lah. So chapter 3 sahaja saya bagi tu. Synchronous generator. Okay. Alright. Okay ya. So petang ni saya akan buat sekejap lagi lah. Dalam give me about 1 hour. Alright, so I will put into this lecture notes dalam Ulearn. Okay. Alright. Also tutorial dalam ni ya. Untuk tutorial pun ada dalam Ulearn. You can tengok lah. Dan juga ada assignment. So assignment you have to do, and then lepas dah buat you can email to me. So kita tutup di sini. Alright. Okay, kalau tak ada apa kita end our session here. So we'll see you on the next week. Bye. Assalamualaikum.
Okay.